Talk about this Cummins QSM11 that we just built. We've got it on our stand here to test and check for leaks and performance. But we seem to be having a problem with this fuel shutoff solenoid right here, coming off the main fuel pump. Fuel solenoid is, this coil happens to be a 24 volt coil. It has a 24 volt signal coming to it from the ECM. And when we turn the ECM on, with the wire off, we're getting 24 volts, but with the wire on, we're getting like 1.80 volts. And it's not strong enough to pull back the plunger to allow the fuel flow to move from the pump, out of the pump, into the ECM for cooling, out of the ECM into the cylinder head for the fuel injection. So what we're going to do is we're going to take this coil off, show you the inside of the coil, and then we're going to run some tests on the coil to find out what the problem is.
Action.
Okay, so I've removed the wire from the fuel shutoff solenoid. We're going to test to make sure we got voltage coming from the ECM. So I'll put my red lead on the wire that goes to the solenoid, my black lead on ground. And if we look at the meter, we got 22.17 volts DC. Now I'm going to put the wire back on the solenoid. Tighten it down. Now that it's tight, I'm going to turn the ECM switch off. And I'm going to put my red lead on the pole, black lead on ground. And you can see we don't have any voltage. It's just showing a noise level of about 300 millivolts. All right, let's turn the ECM switch on. I got 24. And it's dropped down to 18.5. So we've got a pretty significant current draw on the coil. And that is about correct. Okay, we have the solenoid and the guts of the solenoid taken off of the fuel pump so we can see what happens here. So we've got the piston, which goes like this. We've got the secondary piston, which goes like that. We have a Belleville washer. It goes like that. These ride in the spacer plate. And then we have a cover here that's not magnetic, it's a dissimilar type material. So when voltage is applied to this coil, it creates an electromagnetic field. It'll actually suck this back in and compress that Belleville washer. So when the fuel is off, it looks like this. When the fuel is on, it'll look like that. It doesn't move much, but that magnetic field will draw this piston back. And the problem we're having right now is it's not drawing the piston back. So to further test this coil, there's two tests that we can run. Test one. Test one will be resistance. This system is a 24 volt system. The coil, this is your positive, and the coil grounds through the frame of the pump. So what we can do is we can test for resistance. The resistance on the 24 volt coil should be between 26 to 40 ohms. Go to ohms on my meter, and I'm simply going to put the red lead on the positive, and I'm going to ground the black to the frame of the valve. Our resistance reading is 31.2. So the resistance is correct. Our target is between 26 to 40 ohms. So that's correct. So that tells me that the coil is good. The second test we can do is we can hook it up. We're going to hook it up to our battery charger, and we're going to energize the coil, see if it's creating a magnetic field, and we'll put a conductor in front of it to make sure it's magnetized. Okay, I'm going to hook the red lead onto the positive pole of the coil. Put the black lead on the coil itself. And then we're going to turn the battery charger on to 24 volts. And then I'm going to put my needle nose pliers in front of this to make sure it's energized, and it's energized. So everything's working fine on the coil. So the coil is not the issue with this no start situation. Now we verified three things. We verified the resistance on the coil, which is correct. We verified that we have voltage coming from the ECM to the coil in start position. We verified that the coil is creating an electromagnetic field by using an external source. Okay, we're going to do a continuity check between the engine block, flywheel housing, starter motor, and the pump portion to make sure that we got a good ground and there's no high resistance anywhere. So I got my red lead in this ground strap for ground. I got good ground there, good ground here. Got nothing off the back of the starter motor that's going to the negative of the battery. I'm going to come here to the pump. And I got ground, but I've got just a little bit of resistance, roughly 0.4 ohms. Come here to the pump. Got roughly 0.9 ohms from the block, 0.7. Fuel pipe 0.5, starter motor 0.4, flywheel housing I got roughly 1.6 ohms. So the ground should be sufficient, but if the ground is not sufficient, then we'll add our own auxiliary ground strap to this coil to see if it'll enter. All right, now we're going to crank the engine to see if we get fuel flow out of the outlet here. I'm going to turn the ECM on and crank. We're not getting any fuel flow at all. So that tells me we still have a ground situation. So what we're going to do now, I've already got a piggyback on here, but we're going to run a ground from the back of the starter motor to the frame of this coil and see if we get fuel flow then. Okay, now I've got a ground run from the back of the starter motor up to the frame of the coil. So now I'm going to turn the ECM on again, and I'm going to go to start, and I can already tell that it's retracted, so we should get fuel. Now we have fuel coming out of the outlet, so the engine will fire now. For some reason, there's an issue with the ground between the fuel pump, the front cover, and the chassis of the actual engine itself, which leads me to believe that the machine that this engine goes in has another ground strap somewhere during the installation process that will create a better solid ground for this area of the coil. Okay, now that we've established that all systems are working properly, we'll go ahead and tighten everything down, and we're going to restart it.